BrickBot is a project that we began about 2 years ago to explore whether we could teach a robot how to build with Lego bricks. The idea was, if you imagine a robot able to learn to assemble anything in the world in the same way that a child assembles Lego, then we could literally redefine how robots work in any industrial setting. Today, if you visit a factory, there are teams of people that spend months and years programming industrial robots to do just one task. It's incredibly tedious, unbelievably complicated, and very error-prone.
The approach that we're trying to take with BrickBot is to use machine learning to take sensor data and then infer what's going on in the environment to then have the robots act accordingly and act adaptively. There's a lot of things that you do when you're working with robots. It's some programming, it's actually mechanical design as well, making things, fabricating pieces that the robots may need to be able to do their tasks. We're looking at ways to make robots easier to use so that we can put these sort of assembly lines together and make them accessible to more people, not just these big companies that have deep resources to do this kind of thing. Traditionally today, if you look at, say, a robotic assembly line, something that's putting together a car, a lot of effort is put into engineering that line to be what's called very deterministic. Everything has to kind of be in its place for that system to work. If you change the design or you change the parts that go into that design, you have to re-engineer everything so that those new parts are accommodated and made deterministic as well.
We design factories today to effectively be single purpose. And the factories of tomorrow are not going to be single purpose. The factories of tomorrow are going to adapt to the needs at any one time. And you might decide overnight to redesign your product. And you know what? By the next morning, the factories learned how to deal with that design change and it's ready to go. This was the realization with BrickBot, is that we could actually train industrial robots in a purely digital setting incredibly fast because it's digital. It doesn't have to be in real world time. Because you can do it millions of times faster, you can train the robots more robustly. They can learn better, they can learn faster. So now you apply that learning not necessarily to Lego, but to any industrial environment where maybe you're assembling a car or a piece of an airplane or an electronic device, whatever. The same thing follows. You've got a 3D model of those things. The robot has to interact with it. It can learn what to do. We've now reached a point where certainly some of the stages of what we're doing in BrickBot are fairly robust. So we're now beginning to test them in industrial settings.
We want to move beyond just Lego bricks, so we want to start looking at more realistic scenarios. So there's all kinds of different brick types. There's like wheels and gears, windows, rooftops, and so on.
Designing buildings, designing products are very, very complicated things. You have to be a specialist to do those things. And as computers get more powerful, computers should be able to take on some of that specialization and make these things more accessible to more people.